when we try to assess the risk on any IT system, we put on front of our eyes the concept of confidentiality, integrity, and availability. And we try to evaluate each component to understand what are the possible effects of confidentiality and what could be the reason of this, what is the possible impact of integrity and what is the reason for this, and what is the effect of availability and what is the reason for this. I will explain it right now. In any IT system, when we look to a single application or a single server, we usually find this server implemented or hosted on a host operating system. This host operating system can be something such as Ubuntu, Red Hat, Windows Server. All of this kind of Windows or host OS are like operating systems. These operating systems will host the front-end service of any application. What do we mean by the front-end service is when we open a specific website, actually we are dealing with the front end of this website. This front end allow the system or the application users to deal with this website. This front end is connected with something called the back end. And in back end, we have the application logic that makes this site work. For example, when you open google.com website, when you open Google this way, just allow me to open the browser. When you open Google this way, actually here you are dealing with the front end of Google. In this front end, you can enter whatever search string that you need to look for, such as searching for the news, for example. And by clicking enter, what will happen essentially is the front end will move this request to the back end, and the back end will start to execute the request. You are doing a search, so in the back end will be responsible in doing a kind of check on the web of the internet to check about the occurrence of the keyword that you entered in the front end. In some situations, we can find the back end is connected with a database. And when we check how front end can communicate with the back end and how the back end can communicate with the database, we will find various methods. One of these methods, for example, is between front end and back end. We can communicate with something called API or Application Programmable Interface, or HTTP request like GET POST option. And I hope you are familiar with what do we mean by HTTP. And between the back end and database, we can use a native SQL query or structured query language, which is used to communicate between the back end and database. So what you are currently seeing now on the screen is a sample of how applications that we deal with it in our real life, especially online applications, are really looks like. So if we are a company that provide a public website to users to send queries or send data or receive payment or send payment, we usually find our front end is published on the internet via a website to the users. And this front end accepts users' queries. This front end should work with a back end in its back. And this back end execute the required business logic to make users' transactions possible. And for each transactions that users made, it should be somehow logged. Like, for example, if we are talking about a bank, we have a front end, which is the e-banking website, where users can log into this back end and check for their balance. So their balance is actually stored inside the database. So user executes the query to check for the balance. Back end will take this request, and then back end will request the data from database, and database will revert back or will reply with the value of the balance. Then this value will appear to the end user. So why do we need from security perspective to understand how applications are formatted? Because in each layer of the layers that you have, you could have a security risk that could impact the overall applications. For example, if your front end utilize non-batched components, this could give the opportunity for the hacker to attack the front end or try to gain access or maliciously access this front end using this vulnerability. So you need to ensure when it comes to confidentiality that back end or front end is patched regularly. If you have admin page for the front end, you need to ensure that this admin page is secured using a username and password. One of the funny examples here is we have a front end feature or we have a kind of application that is called or platform called Apache. Does anybody familiar with Apache as a web platform? Okay, Apache is simply like a platform that you install on top of the Windows or Linux, mainly on top of Linux systems such as Red Hat and Ubuntu, and it allows you to deploy website over it. You, website is simply like an HTML code, the code written in HTML language, and this code can be installed or can be deployed over a web platform such as Apache. In order to allow or deploy your website over Apache platform, you need to log in to the Apache and then you will browse and you will upload the HTML file of your website. Make sense? The problem is for most website administrators, Apache comes with default username and password. And this default name and password was, I believe, something such as null, which means it does not use username and password at all. Okay, so the administrator install Apache and log into the Apache and upload the website and activate the website, and then it leaves the system online on the internet. The problem is if someone understood due to scanning and discovery that this website is based on Apache or built on Apache, he can try to open the default admin page of this platform. And if the administrator does not change it, the login credential or the default account of accessing the Apache platform, the hacker will be able to access this system using the default username and password. He now has the access not to the website, but to the platform that have the website built on top of it. So he can simply remove this website and upload a new one and type that this system was hacked. The motive or the reason why hacker can do something like this is not necessarily to take data, but to impact the reputation of the organization, for example. Imagine you are a security service provider and your website got hacked, or a bank and your e-banking got hacked. Imagine the effect of such incident on your reputation as a bank or as an organization specialized in a certain matter related to security. Clear? So when we look to every component in the architecture that we have here, we might think about the confidentiality aspect for the front end. So we evaluate what are the different threats that could impact the confidentiality. When we talk about the integrity, in this case, we need to ensure that when somebody stay at home, try to browse our front end and send a request for transaction for money. So he need to make a transaction with $100 from one account to another account. If this connection from the user to the front end is not secured, using a protocol such as HTTPS. Do we are familiar with HTTPS? Other team, please. So, when we talk about communication from the regular internet communication, assuming that I am now opening a website here. This website is opened using a protocol or a way of communication called HTTPS. Can you see the word here on the screen? HTTPS. What do we mean by HTTPS? We mean that we use secure protocol to transfer data. Let me elaborate this in a meaningful way. So I hope the information till now is clear. And as I mentioned, if anybody does not know a specific term, just let me know. In network communication, we have, when we open a website, we can open the website and it will give us this sign, this look, or this bad icon. This bad icon essentially means that this connection is secure. And it is secure, we have a kind of encryption in place. So whatever data that my device is sending to this website will be migrated or will be moved through a tunnel or encrypted tunnel. In case anybody try to inspect or intercept this traffic, he will not able to read anything. But if I am using non-encrypted protocol for the communication, the request can be intercepted with anybody in the path of this traffic. For example, if you are using a public Wi-Fi in cafe or a restaurant or an airport, you of course not only the one who use this service. You can also have a lot of users who accessing the same service at the same time. If one of these users has a malicious intention, he can do a kind of attack that is called the man in the middle. In man in the middle attack, this intruder or this malicious one will intercept the traffic, and instead of allowing you to move the traffic from your device to the front end of the website, the traffic will go to this user first and then will be inspected by this user and then will be sent to this website. Can you understand this? In this case, this user could have the possibility to play with the data, which means while you are trying to transfer $100 from your account to your friend account, he can modify the request, and instead of specifying your friend account, he can add an overseas account. And this account is outside of the country, and you will make the transfer and then you will not be able to restore your money back. So this is a possible impact on integrity. Do you remember when I was telling you that you need to consider confidentiality and integrity and availability. So you evaluate confidentiality problems, could be related to authentication, could be related to patching. And then you evaluate the integrity issues, which could be related, for example, to the integrity could be related to existence of someone who can intercept the traffic, and then he can modify this request, so he can mess with the data. For the availability, you are concerned about what if this my website was subject to a severe attack, and this attack can cause this site to goes down, which can impact my reputation and can impact my level of service that I can provide to my customers. So in this case, we need to consider, for example, an additional website or a secondary instance for this website. So in case the first one goes down, the second one will be operational and will be working with no issue. So I will leave it to your imagination, but when you try to, you will apply the same for the back end as well. So you will think from the confidentiality perspective. Is anybody can access the backend unless authorized? You may think about this. Yes, that's possible because backend does not have authentication in place or use a shared account. And this shared account is known by all employees in the IT departments. So you need to think about a possible solution for this issue. About integrity, yes, integrity can be affected because we use non-secure protocol between front end and the back end, which is HTTP. So in this case, we need to use encrypted protocol such as HTTPS. Okay, you will think the same about the database. Database is not secured, confidentiality, integrity, or we have a single database. We don't have high availability for the database level. So we might think about how to make a secondary instance of the database. Regarding the host operating system, we may consider that the host OS need to be regularly patched, need to be monitored to ensure that we will not have a severe impact that could affect the host level. Remember, in cyber attacks, we can attack the front end, and by attacking the front end, we can take over the entire machine. And in also we can attack the host operating system, and it is the same. We will take over the whole operating system or whole data on this machine. So any of the elements that you have on the screen right now is the possible entry point for different cyber threats.